Hello, everybody. So thanks for joining today's webinar, which is part of Operate project, which is about alternative weight control. This is a European project involving different countries. So today we will focus on electric weeding and we'll have case studies about various crops, vineyards, grassland, and fruit production. So I will briefly introduce the webinar program, and then I will let the speakers present. So we'll have a short introduction on alternative weight control and Operate project itself. So that will be about 10 minutes with the Agricultural University of Athens, which is the main coordinator of Operate project. Then we will focus on the solution electric weeding. We will spend about 30 minutes on it with 3 different presentations. We will start with ADAS, which is an independent provider of agricultural and environmental consultancy. They are from United Kingdom, and they also do research and experimentation. Then we will also have a presentation of a Rootwave company, which is developing e-weeding solutions and which is working with ADAS in that project. Then we will finish with IFV for Viticulture. So this is a French Wine and Vine Institute working within the different wine regions of France and doing research and development from grape to glass. And in the end, we'll have a question time, about 15 minutes. So you can't talk, but you have a question window on the right of your screen, right side of your screen. So you can write your questions and we will address it in the end of the presentation. So now I will leave the University of Athens start with Ilias Travlos and Nicoleta Darra.
Thank you, Camille. Thank you all for being here today. It is our pleasure to have this first webinar of a series of many that will follow. And I would say that we are very glad that I consider this is the perfect timing for such a project, and I will explain what I mean. I'm Professor Ilias Travlos from Agricultural University of Athens, and with my colleague, project manager, Nicoleta Darra, will tell you a few things about solution for alternative weed control. And the truth is, yes, Nicoleta, you can proceed. The truth is that the challenges are out there since, next slide, please, Nicoleta. The challenges are out there because we are talking about a difficult case, a difficult reality, since herbicides pose a severe environmental threat. Moreover, we are all aware of Green Deal requirements, meaning that very soon every European country should reduce 50% the use and the risk of pesticides, including herbicides, and this is something very difficult and very challenging to achieve. Also, we all know that crops need many things to produce, to have good yields, and this is something really important for the farmers. So we need to suggest something really innovative here. But the issue remains that it seems that in farmers and advisors, this information is not very easily spread, I would say. It's not very easily adopted under the real farm conditions. Yes, you can proceed, Nicoleta. To say a few things more about the problem, I would say that please note that herbicides have been very successful, especially in the past decades, and they account for 32% of all pesticide sales. Another issue is that the national and sectoral agricultural knowledge and innovation systems the ACIS systems, as they are widely known, are insufficiently connected and organized, meaning that we have to act to make the flow of innovation and of knowledge easier for everyone. Another issue that makes the problem even bigger is that many of the herbicides have developed resistance. The weeds have developed resistance to many herbicides, to many important herbicides. We are now talking about more than 250 weed species with proven herbicide resistant. This is something very tricky, very difficult to manage. And also very often, as we can see it with our networks, is that very often farmers and advisors are not very keen to adapt non-chemical methods because of the cost, because of the complexity, because of the time needed. Many reasons can be the cause of such a problem. So Operate, I would say, comes here to suggest and to highlight some of these methods and the benefits, the potential benefits of such an alternative weed control, as you will see today, are multiple, are many. First of all, we are talking about a clear reduced environmental impact, an improved soil health, the diversification, which is important for keeping all the methods effective, the increase the profitability, which is the main purpose of agronomy itself, and also the improved crop quality. So, as you can see, the benefits of such a of our project, of the methods that we are going to suggest, have to do not only with the farmers or the advisors, but also with the consumers, with the products themselves. So let me give the floor now to our project manager, Nicoleta, can tell you a few things more about Operate project.
Hello, thank you for attending this webinar. I will talk about for a few minutes for Operate project. As you can see, Operate will set up a self-sustainable multi-actor EU-wide thematic network to support and promote solutions for non-chemical weed control by building upon the knowledge and outcomes of 8 operational groups all over Europe. As you can see the map, these are the countries that are involved in this project, and we also will involve relevant actors and stakeholders. The main project objectives are to establish the thematic networks and set up national networks. In each country, we will set up national networks, and then we will then connect them to an EU-wide entity. Then we will identify grassroots needs, gaps, and barriers. This will be realized through questionnaires and focus groups. Also, we will create an inventory of solutions for alternative weed control, and then we will scale up all this knowledge through cross-fertilization activities and the produced material like practice abstracts, audiovisual material, and training. In this context, we will also communicate, disseminate, and have demo farms in order to scale up all the outcomes of the project. As we can see here, we have the Operate thematic network. We will, in this phase, we setting up this network, and then we are capturing the needs and barriers through survey workshops and literature review. And then we analyze these results and incorporate them to an inventory. We also include the cost-benefit analysis and workshop for readiness and acceptability in order to see which solutions are fitting to which countries. And then we have the scale-up and cross-fertilization processes, which are best practices, practice abstracts, learning videos, etc. And also we have the communication and dissemination channels, and we will also connect with other relevant projects as well. This material will be also translated in many languages. As you can see here, you can see the approach of the project. We want it to be bottom up and top down as well. So we will ask from bottom, from partners, from farmers and industry people, and also relevant stakeholders to ask their view, their opinion, and their knowledge. And then we also have the top-down approach, which is a literature review. We will have also expert panels. And then all this will be combined to an inventory that will produce all the outcomes of the project. I want to show you also a few case studies of the project. As you can see here, in each country we have demo farms. There we will show the solution of operational groups that we already have, but we will broaden these activities to exchange these solutions from one country to another. As you can see, the first image, we have the mechanical weed control by robotic means. Then we have a biological method of weed control with herbivores in Spain. We have a herbicide dosage map in Sweden. And of course, image analysis of UAV data to identify the weeds. Another application is in figure 5, where there is a weed control with hot foam, as you can see here in Greece. And also we have front mountain electric weeder prototype in black currants in UK, and laser weeder prototype in Latvia. So these are a few of the demo events that we will hosting throughout the duration of the project. And I will be happy if you also follow the activities because we will have more interesting events within the time of the project. Thank you very much.
Thank you, Nicoleta and Ilias. So now we will switch to Lynn Tatnell and Godfrey from ADAS in the United Kingdom.
Okay, thank you, Camille. I hope you can see my screen. Okay, good morning, everybody. My name is Lynn Tatnell. I'm a weed biologist based at ADAS in the UK. I've been involved in weed management research for 26 years, looking at all aspects of weed management, but I have a particular interest in alternative weed control options, and particularly IWM, integrated weed management. So Kevin and I are going to do a joint presentation today. So we're going to start the presentation by talking about some work we've developed in blackcurrants over the last 5 years. So this was very much proof of concept, and talk about some of the machinery development in the early stages. And then we'll be hearing from Tom after our presentation with some more up-to-date work and machinery development in the UK. And then Kevin will be talking about perennial weed control. So this is focusing on some work we've done with dock species, rumex, and how this could fit with IWM tools. So why electrical weeding? We've just had a nice introduction from Ilias there on the background and the issues, but we're obviously at a point where we have an increased requirement for non-chemical control options. There is a loss of herbicide choice, so conventional growers that are looking for herbicide options, they may be limited now due to things such as pesticide approvals being withdrawn, or a lack of new modes of action, new chemistry coming through. Herbicide resistance is increasing. This is a global problem. It's a very serious problem for cereal growers. So particularly, say, in the UK, cereal growers that may face a big problem with grass weeds, such as blackgrass. And this is also an issue across Northern Europe. So this has been made worse over the last few decades with limited crop rotations and people relying very heavily on herbicide control only. So there's also been a very heavy reliance on glyphosate. This has been used in many different crops, perennial crops and annual crops on a global scale. Again, glyphosate is under threat for many reasons, including potential loss of the active, but also people are now requiring to or urgently looking for alternatives to this herbicide in particular. So we have other options. We have hand weeding. That can be very expensive and very slow. It can be very effective. Mechanical weeding. Again, very effective, lots of brilliant tools out there, excellent machinery. However, it does disturb the soil, it moves the soil, and that gives the weeds an opportunity to germinate. So if you have quite a high seed bank of weeds, they may have that opportunity to germinate. So with electrical weeding, it provides an alternative, a different method of control. We can be quite selective if you have height differences between the target crop and the weed species. There's flexibility. We can travel in windy conditions or directly after rain. You may not want to travel in the rain for various reasons, but it does give you the chance to be very flexible with this kind of control option. In the amenity sector, it's already very popular. So you are able to buy kit already in the UK, and the public perception of this being a more environmentally friendly option. This is something that certainly the public are very keen on, and it is being used very widely already in gardens and parks and amenity areas. And I put on here, it allows for pests and insects not to be controlled. I'm thinking of things like beneficial insects, earthworms, so things that you're not directly trying to kill will obviously not be affected by this kind of treatment. They sadly would be if they were in direct contact, but obviously if they were just in the area, it would not be a problem. So I'd like to start really by just going over some trials work that we've been involved with, looking at application timings and travelling speeds, so you can understand the technology a bit more. The crop we focused in was black currants, and we did work in other bush and cane fruit as well, but I'm just going to cover black currants today. So we looked at different timings, whether you just do 1 pass, 2 passes or 3 passes, and we tried to spread these out for a good 2 or 3 weeks apart. This depended on the season and on the weather conditions in those seasons. Travelling speeds, we were looking at fairly slow speeds, so 4 or 2 miles per hour. We had a lot of discussion with our steering groups at the beginning of the project. Some people were in the opinion that this was very slow, but it obviously was machinery in development at that point, so it gave us the opportunity to understand how it was working and how we would get in contact with the weeds. We had very large strips of treatment plots, which were 30 metres long, down a crop row, an untreated control area, so we were able to take the machinery and use it to its best ability down for a very long treatment area. And then obviously we did the usual assessments of weeds, visual scores on the day of treatment, observations, and then 1 to 4 weeks after treatment and 6 months after treatment. So just to show you some of the challenges of the crops that we've been testing in, I'll just take my pointer. So this is a mature conventional blackcurrant crop. So you can see the crop rows here, and this is a grass strip down the middle that will be mown. These are the herbicide strips. So we were doing some of our testing in this area where obviously these have been treated already with a herbicide, but where areas that had not been treated. But we also tested in organic crops. So this is a newly converted blackcurrant crop. In this particular grower uses the plastic mulching around the base of the newly planted bushes here. But again, we're targeting this area down the side because you don't want the weeds to be growing up into this area, coming into the base of the bush and up through the bush, because it obviously affects issues with harvesting. So a bit later on, you can see as things have matured and we carried on with our trials, the growth stages of the weeds can be quite challenging in this work. So we have, hopefully you can see here, these are perennial weeds. So this is creeping thistle, Cirsium ovense, and you get lots of weeds coming in from the grass margin strips. So some of those can be very low to the ground and very difficult to control. So as this area does remain quite bare when they've had a herbicide treated strip, obviously it's an ideal opportunity for weeds to come in if there's not a big residual effect from the herbicide. And again, showing some pictures of this is a different organic crop with mature blackcurrants here. You can see how much grass we have. So this is quite a challenge and was quite a challenge in our trials. Again, very close to the base of the bush. So this is a problem with particularly perennial weeds in the future coming up through the bush and issues with harvesting. I want to start by going through some of the machinery development and how that evolved over time. So this is back in 2017 when we started this work. So it was run in the UK by the Innovative Farmers Group, and we had funding from the EAFRD. The project was led by the Soil Association in conjunction with ADAS and Rootwave and the grower Anthony Snell. We also work with Suntory, so they're a drinks manufacturer who make Ribena and from UK blackcurrant, so they were actively involved in the project with one of their agronomists, Harriet Prosser. So we started with electrode design. This is a very long time ago now, but we looked at different electrodes on the back of a tractor mounted system. So it's attached to the PTO of the tractor. We trialed it in different areas. We were testing different kit, looking at how the electrodes made contact with the ground, made contact with the base, into the base of the bush. So how close could we get? But very quickly, we moved on from that, and in discussions with the tractor driver, actually, he said it would be easier to have something mounted on the front of the kit so you could see where you were driving. So in 2018, we ended up with the next stage of development with the large box mounted on the front of the tractor. Again, the electrode array here and a big guard on the side so it doesn't affect the bush as it goes through. And then in 2019, moved on to, again, yet another design with this folding arms with a different array of electrodes. So these are all the electrodes that make contact with the weeds, but the arms fold up on a box on the front and can move and tuck in under the base of the bush when they're extended. So we moved through this project with lots of different machinery development. And again, Tom's going to move on to the next stage of that in his discussion. So I want to show you some of the results and some of the work that we had from the control. So I'm going to focus very much on the perennial weeds here. So this is again creeping thistle, Cirsium arbensi. You can see patches of creeping thistle that come in this untreated, what would be the herbicide strip. So these can get very large and have a big network of roots underground, obviously causing problems for the future. When the electrodes pass the weed, they're obviously making contact and the electricity is earthed down through the plant. So it's actually causing the cells of these plants to erupt and burst, and then the plant basically dies. So you can see in this picture, it's turning black, the cells are dying, and this is just within 10 minutes post-treatment. And then within 2 weeks, in this situation, you can see complete kill. So this trial year was actually very hot and dry, and we were getting this complete desiccation on most of these treatments. These farmers based in Herefordshire in the UK. So this is what we were seeing just after 2 weeks. So in some of these trials, we didn't need to go through to the 4 and 8 weeks assessments because we had complete kill very quickly. But I just want to show a different density of weeds. So they weren't all creeping thistles. So in this particular trial, we had a dense canopy here. So some of these this is mainly mayweed, Triplurospermum inodorum, and swineCress, which is Coronopsis scorpimus. So you can see with the dense canopy here, 2 weeks post-treatment, we've still got very, very good levels of kill. We've got a few little bits that were left, and in this particular trial, we had one electrode that wasn't working, so we could see the stripe down the trial, but again, it was a prototype machine. We just wanted to show you some differences in the weed control levels. So to put that into context, I'm briefly going to show some results. Again, there's a full report available here. You can find it on our website if you look at the link after the presentation, but just to show some of the differences in the timing. So I said we were going in 1, 2, or 3 timings. So I'll start with the graph on the left-hand side. This is the summer treatment, and you can see the blue bars are it was actually kilometers an hour, and the orange bars were 3.2 kilometers an hour. We couldn't get a big speed difference again with this particular prototype machine, but just to show you some differences. So initially, at the lower traveling speeds, we were getting higher levels of control of the weeds, and we think this is probably due to the contact time, and you've got more time, particularly with the perennial weeds, where the electrodes are in contact with that weed. But you can see after we've done 2 passes, there's absolutely no difference between the travelling speeds in this case. We ran this trial again in the autumn of the same year. Again, slight difference between the speed. So at the slower speed, we're getting a slight difference in weed control. And again, after 2 passes, again, slight difference, but very close. So I've pulled out some data very quickly to show you some differences. We actually had some quite challenging times for these trials because the first year was very wet and we had a lot of grasses that caused the problems with control, and the second year was very hot and dry, so we were getting the trials were over very, very quickly. So we had the usual kind of trial issues, but if you'd like to see the full data, you can find the report on our website. I'd also like to touch on another area of the research very quickly. We were interested in how the electrical treatments were affecting the soil, and in particular the microbial activity. So we took some soil samples to look at the level of microbial activity, and this is called a CO2 burst test. It's a measurement that's taken in milligrams per kilogram. So we took soil samples on the day of treatment in an untreated area and the treated area, and then 7 days post. So just to explain the scale here, a reading very low is less than 15 milligrams and very high is 105 to 123 milligrams. So you can see for our untreated plot and our treated plot on the day of treatment, we were getting a moderate reading across our 3 reps. So this is 25 to 45 milligrams. But the soil sample we took 7 days post-treatment, we actually got a high microbial reading, which was fairly positive. And we think this could be linked to the dying plant material that's going back into the soil and the carbon's being released in that time. So this was just a snapshot. We just did this in one of the 5 field trials that we had, but I think this is something for further investigation and certainly was very much of interest to us. And then finally, I just want to show a few other learning points that we had from these trials. So for us, it was interesting to see how crop orientation made a difference to the level of control after 6 months when we came back to view these trials and to assess them finally. So where crops had been orientated in an east-west direction, we got this shading effect down the northern side, and there was obviously a lot more moisture in this area, and the grasses and clover had all crept back in. Whereas when we had the treatment on the sunny side, you can see even after 6 months, we're getting a high level of control. And this was true, this was actually one of the organic fields. Again, you can see on the shaded side, we've got a lot more clover and dandelions and things coming in. So it was just another interesting point and something to think of when you're thinking about control in the future. So to draw some conclusions, and sorry, this has been quite a whistle-stop tour of our trials, but you're very welcome to contact us afterwards for more detail. So really, we can say that multiple treatment timings have improved control. So 1 or 2 timings, or certainly 2 timings is very good in this case. Slower traveling speeds appear to improve efficacy. So are we getting more contact with the weed? This obviously requires more testing to evaluate. It may not seem appealing to some people if you're having to cover a vast area, but perhaps the slower traveling speed will mean you may not need to make so many passes. So again, something to evaluate in the future. The control of the perennial weeds in these trials has been the most obvious, the most dramatic. We were seeing really, really high levels of control with docks and with the creeping thistle. Grasses were very challenging, I will say that. So integrating this system with mowing could be beneficial. This needs further testing, but this is something we were trying to do in year 1 in the organic plots where we had a lot of grass present. So learning curves, other things such as the moisture level and the orientation of the crop if they're row crops. So this is all things we needed to consider. But overall, I think we can say in this case that electrical weeding is an exciting IWM tool and something to very much consider for the future as the technology is now advancing. So I'm going to hand over to Kevin at this point to talk about more electrical weeding trials in grassland. Thank you.
Yeah, Kevin, so you have about a bit between 5 and 10 minutes for that. Is it fine?
Super, yes, thank you, Camille. Yes. Can you see my screen?
Yes.
Super, thank you. Morning, everyone. So I'm Kevin Godfrey. I work for RSK ADAS with Lynn Tatnell, and I work in the weed control department with a particular interest in alternative weed control technology. So I'm just going to give a brief overview of one of the original European Innovation Partnership projects that preceded Operate. So this project evaluated electrical weeding, controlled docks in grassland systems in Wales. So to provide a bit of background, docks can be a major problem in grassland systems in Wales, particularly in dairy farms where there are high levels of nitrogen, along with other factors encouraging dock growth, and that will lead to reduced grass yields. So many of the herbicide options available are not clover safe, and therefore they will eliminate the benefits of fertility building and the quality of the sward. And it had also been noted that grassland farmers were often reliant on contractors to carry out herbicide applications, and the arable fields were being prioritised, so the docks were often too big when they were being treated by the contractors. So the trial just aimed to evaluate a proof of concept using the Rootwave Pro that's usually used in amenity settings. So there's a picture of the handheld device on the middle picture of the screen. So yeah, very much just to kind of evaluate that proof of concept, as there was no commercial electrical weeding kit available at the current time for grassland. And then we were just also having a look to see, as well as it being an option for non-chemical methods of control, also to see if it could become an integrated method of control and therefore combining with herbicides. So for the electrical weeding trials, we carried out trials over 2 different years on 2 sites in each year, so on 3 sites in total. And there were 6 treatments applied at each time, and these were replicated 3 times on 6 by 2 meter plots. In the second year, we applied electrical treatment at 2 times per year and 3 times per year. And then we also looked to combine the electrical treatment at timing 1 and then a herbicide treatment at timing 2. And then also reversing that with a herbicide treatment at timing 1 and electrical weeding at timing 2. And then for comparison, we looked for a treatment with just a conventional herbicide treatment that was a herbicide that wasn't clover safe. And then as further comparison, we used untreated control. In year 1 of the trial, we did look at just treating once with the electrical treatment, but we felt that it wasn't robust enough. So for the second year, that's why we increased to 2 and 3 times and looking at the integration of the herbicide into the mix. And then for assessing the trials, we looked at percentage weed cover of the docks, and we assessed this at 2, 4 and 8 weeks after each of the treatments. So here's just some photos just to give you an idea of what we're working with. So the picture on the left-hand side shows someone applying the electrical treatment with the handheld lance. This is the Rootwave Pro that's available for kind of amenity settings that Tom might touch on later. Essentially, you've got a 20-meter cable attached to the handheld lance, and that cable is then connected to a generator that's on the back of a truck to provide the power. And then we were basically touching each of the docks for 5 to 10 seconds just to knock those back. So the center picture is a picture of kind of the growth stage for the docks that we're aiming to treat at. And so that was before treatment. And then on the right-hand side is a picture of one of the docks post-treatment. And you can see there's immediate knockback of the above ground growth of the dock. So that was nice to see. And then onto some results. I've just picked out results from one of the trials in the second year. It was a site that had a particularly high weed burden with docks that were very large at treatment timing. So when the herbicide was initially applied, the docks were probably larger than optimal, and that slightly reduced the control of the herbicide. So just to go into a bit of detail with the graph, we've got the blue bars that are just showing assessments 4 weeks after the final treatment of the season. And then the orange bar is showing the percentage reduction 8 weeks after the final treatment. And so all assessments are made from a percentage reduction compared to the untreated. So if you look to the far right-hand side, you can see 8 weeks after treatment, the herbicide alone treatment has just over 40% control compared to the untreated. Obviously, this is low, but that was due to it being treated at a more advanced growth stage than would be optimal. And then if you go to the far left-hand side of the screen, you can see that the electrical weeding 2 times per season was also very low with just 10% controlled. However, once we treated it 3 times, you can see that's jumping up to just over 50% controlled, so comparable with the herbicide alone. And then what we found particularly interesting was the integrated approach of using the electrical followed by the herbicide, or reversing it and the herbicide followed by the electrical, was showing just an increased level of performance and reduction in the docks. So we thought this was quite exciting, that it's reducing the level of the docks, and we're quite keen to explore that kind of integrated approach, one with using a different herbicide that's potentially clover safe so that we can retain the clover, but also integrating cutting into the system to weaken the docks, and then following that with electrical weeding. So just to quickly conclude for the project trials that we carried out with the electrical weeding in grassland. So we concluded that the electrical treating 3 times per season was equivalent to a herbicide application alone in these trials. We were seeing that the integration of herbicide and electrical treatments was very effective, and that was something we're interested to test in the future, particularly with the clover safe herbicides and the cuttings as just mentioned. And then the electrical weeding is obviously going to help to retain the clover in the grass sward due to the spot treatment in these trials, but we're also thinking if it could be developed into a commercial model that could be used to kind of treat the docks when they're at higher growth stage than the grass sward, a bit like a weed mulcher would be used, then that would still retain the clover in the grass sward, so that's beneficial. And this tool could be beneficial to organic farmers, but also those that are requiring lower herbicide inputs, as Ilias mentioned throughout Europe we're looking to achieve. So we thought it'd be a promising additional tool for weed management in grassland, but we would need to develop that into a commercial model, and therefore that would need to be tractor mounted rather than the Rootwave Pro that is just used for the amenity settings. And finally, if this piece of kit was developed commercially, obviously we'd need to look into the economics of running the system, and this wasn't considered as part of the trial because it was just mainly a proof of concept. Then finally, as with Lynn, both of the project reports are available at the website on the screen. So yeah, please do go and check them out. And if you have any questions, then feel free to email both of us. And then if I pass over to Tom, who's going to talk a bit more about the more kind of updated versions of what Rootwave are working on. Thank you.
Great, thank you very much, Kevin. Okay, good morning, everyone. Nice to join you this morning to talk about e-weeding, which we're, as a company, Rootwave, we're really excited about. Okay, so a little bit of history about Rootwave. So we're a UK business. We're based in the Midlands of the UK in Warwickshire. We have 45 employees, and we are a leading e-weeding company. We have sales in UK, France, Germany, Netherlands, and Nordics. So all European based at the moment, but looking to expand further as we develop our solutions. We've been commercially successful for the last 5 years with our handheld product, the Rootwave Pro, which you've seen on Kevin's slides previously. But we're now launching our new e-weeder into top fruit and vineyards in UK and the EU. And I'm going to talk about this a little bit more this morning. So in terms of the key features of e-weeding, so e-weeding improves resilience by removing the key input, which of course is chemical herbicides. So it's zero chemicals. And as a result, e-weeding helps nature restore soils, water and biodiversity, because you don't have the negative association with non-targets being affected by the side effects of chemicals through going into the wider area of the environment. E-weeding supports regenerative agriculture and can be used in regenerative systems. Also, there are no restrictions about treating near water and environmentally sensitive areas as well, so we can get very close to that when treating weeds. Operating in a range of weather conditions, crops as well. So as Lynn pointed out, it can be used immediately before rain, immediately after rain, but not during rain, really because the system isn't 100% waterproof. However, it can treat in very low temperatures. You can treat at night time because that won't affect the efficacy on the weed target. And also our studies have demonstrated that it can be cost competitive with herbicides as well, because we don't have the consumable cost of herbicides. The only marginal additional cost is a slight increase in the fuel used to run and operate the tractor. However, saying that, it's compatible with green energy sources as well, and it's ready to be used with autonomous vehicles. So we really see weeding as a weed control tool for now, but also the future. So certainly is effective and sustainable, and it's the only technology that's really competitive with herbicides from an efficacy point of view, in our opinion. And it's also compatible with regenerative agriculture. So if we look at the left of the slide here, the yellow boxes, so we have the chemical solutions, which are synthetic chemistry. Now we know that they've been very successful over the years, but then there's concerns around the use of the synthetic chemicals longer term. There's also the biological options. However, generally no broad spectrum solution. There's uncertainty, regulatory pathway, and of course the time to develop and time to market can be quite a long time. And from our understanding, it doesn't really kill deep into the roots of the plant. So, for example, you might have something like pelargonic acid, which will burn off the surface of the plant, but it won't be systemic and go into the roots. But however, electricity, e-weeding, it is systemic. So in some ways, it's similar to glyphosate, that it's both contact and systemic. So that the heat energy of the electricity transfers right down into the root of the plant, so it gives full control, and that's why it is so effective at killing weeds. But then if we compare to other physical methods such as mechanical, so negative effects of mechanical, damaging the soil by obviously cultivating and disturbing it, carbon emissions, so there needs a certain degree of torque to be able to power machinery, erosion of soils, potentially biodiversity loss. So we've been speaking with organic farmers who really want to hold off on some of the mechanical weeding operations, because if they go in too early, it can kill and reduce the numbers of beneficial pests, that is soil dwelling, that hatch out later in the season to give other benefits. So there's a negative association there. And of course, mechanical doesn't always successfully kill the roots of the plant, so therefore you get regrowth. And as Lynn said previously, the weed seed bank, new germinating seeds will grow as well. And then we have a look at other physical, such as thermal. So thermal generally is very energy intensive, and therefore it burns more carbon currently if it's with a combustion engine, but also increased cost, and it does not necessarily kill the roots, therefore more treatments required as well. Okay, so here we are, we're introducing our new product here, and this is our e-weeders for orchards and vineyards, and this is the tractor powered machine that is launching in the UK and the EU. Now we've coined the phrase better weed control because we really believe that e-weeding or electrical weed control is better weed control from virtually all different angles and approaches that you come from. So this particular machine is precise in application, and it provides full control of weeds within the tree or the vine row, so under the vine row or under the tree row in orchards. As I said, better efficacy, so systemic weed control, so that's great. So we have long-lasting effects, and depending on the season, you may only require one treatment. So if it's like 2022, when it was very hot and dry, an early season application may have meant that actually other weed control was not required for the rest of the season. However, our assumption is that probably on average 2 to 3 treatments per season, so similar to that of the herbicide applications, and I think that would probably be a realistic assumption there. And treating deep into the roots, very effective and very important for controlling these perennial crops. Better safety as well. So Rootwave is the safest e-weeder, and the reason why that is the case is that we use something called a high frequency waveform, and this high frequency waveform is intrinsically safer than direct current, and it's intrinsically safer than sort of our domestic supplies that we have, electrical supplies into our sockets, which is 50 Hertz frequency. Our high frequency waveform is actually operating at 18,000 Hertz and above, and as a result, this is intrinsically safer, meaning that it is 10,000 times less likely to result in a serious safety event than compared with domestic household supplies of electricity. So it's not only do we have excellent efficacy, but it's also excellent safety, which of course is really important for us. But also when we're looking at farm operations, it has better flexibility. So we can treat when windy. So we're not limited to particular spray days and farmers having to get up very early in the morning to get into still weather and to treat. Immediately before and after rain, near water courses, and also we can treat when best for the crop and best for the busy farm schedule. So this gives more flexibilities for the growers. And better for soils too. So in our studies so far and our analysis on the effects of macro and microfauna, we haven't seen any negative effects, and also no negative effects onto the crops either. So this is really good, and we actually think our solution will allow soils to heal and capture more carbon. Okay, so in summary then, so it's an 18 kilohertz high frequency system. The treatment width is, the treated area is 0.3 to 0.6 meters either side of the machine under the row. We can go up to 5 kilometers per hour. It's versatile for a range of crops, range of perennial crops. We can treat varying row widths, so the machine is adjustable to treat widths from 1.8 to 4 meters wide, and it's powered by a 75 horsepower tractor, so 75 horsepower and above. And very quickly, you can see here on the left, we have an untreated control. This is an organic orchard in the UK last year. We had a single treatment of the Rootwave e-weeder. You can clearly see a treated strip along there. And then this will be the mechanical weeder as a comparison. So this particular trial gave over 94% control of all weeds from the e-weeding solution. We've also conducted trials on another range of crops, including maize, sugar beet, and also non-crop as well. And we've always had excellent performance from the e-weeder on the different weeds present in these trial scenarios, and compared very, very favourable to chemicals. And in fact, in probably 3 out of the 4 scenarios, we had higher levels of control versus the chemicals. So really, in summary, Rootwave is better weed control, and we can deliver the most effective, economical, and probably environmentally friendly weed control solution on the market. Thank you. Thanks, Camille. And handing over to Christophe now.
So thank you, Tom, Lynn, and Kevin. So now we'll switch to viticulture with Christophe Gaviglio. We are a bit late, but we will still allow time in the end for the questions.
Okay. Can you see my screen now?
No, not yet.
Okay. Is it all right now?
No.
Still no? Oh.
You want me to share it?
No. Can you give me the hand?
I think
Okay.
I've given you the hand.
Okay.
Camille, do you want to do you want to say?
I can try. Yes.
Yeah.
Okay. Do you have the end? The hand? Sorry.
Yeah.
Okay. So I will try. So that will be the other one. Christophe. Can you see it?
Yes, seems to be right.
Is
Okay.
it a good screen?
Yes.
Basicule, the first one. Yeah. Perfect.
There we go.
Thank you. So good morning, everyone. The last one to talk, I'm Christophe Gaviglio. I'm working in EFV, and so I'm specialized in mechanization issues and also in soil management processes. So I'm here to share some experience about using and testing electrical weeding in vineyards. The next slide.
Yes.
The first thing I would like to explain to everyone is why we consider that electrical weeding might be an interesting solution in vineyards and an interesting alternative to herbicides. A lot has already been said, so I won't be long, but it's clear that soil tillage, for example, has some disadvantages. A lower efficiency, a short-lasting effect, erosion, and I would add something else. Soil tillage leaves an uneven soil, which is uncomfortable for other interventions with a tractor. On the other side, the promise of electrical weeding is to avoid tillage and to avoid erosion while increasing efficiency through a more complete impact. If the electricity reaches the weed's root system, there are more chances to obtain a longer effect and longer impact, and the consequence would be less interventions, which is crucial regarding the cost of weeding in the vineyard. It might leave the soil flat and even, which is an advantage. Next slide, please. Thank you. So in a few words, what do we want to assess in our trials with electrical weeding? The most important thing is the efficiency assessment in the most difficult conditions, like stony soils, like in slopes, or with perennial and persistent weeds and their big root system. Then we want to assess the impact of different factors like speed or weed density to determine the best conditions of use. We have also conducted very specific trials to check any possible impact on the vines. We wanted to know if electric weeding was harmful to the vines. Turns out that no, hopefully. And finally, we've conducted some measurements about the impact of soil of electrical weeding on the invisible soil compartment, earthworms, bacteria, and so on. Mushrooms also.
Sorry.
Here is a visual appearance of the raw electrical versus mechanical weeding. Not so much to say in complement of all that has already been said before. Here's a close-up view of thistles totally destroyed by electrical weeding. So we've learned that electrical weeding is really efficient, but to maximize its efficiency, we've also learned that speed is really important. We have a very clear difference in terms of efficiency between using the machine at 2 or 3 kilometers per hour. We've also a big difference in efficiency with low or high density of weeds, because we guess that there is no impact on the root system or less impact on the root systems in high density weed conditions. We've also assessed that soil moisture can be an issue, even if it's possible to use a machine right after the rain, when the soil is too wet. I think the electrical impact is not the same as in very dry soils, because in dry soils the only conductive part is weeds that are to destroy, whereas in wet soils the soil can also be a little bit conductive. We've learned that yes, you can use electrical weeding in stony soils, which is a big advantage versus mechanical weeding. And we've also assessed that it takes sometimes a little time to show efficiency on some weeds like grasses, but I guess the other person have the same observations. Grasses seems to be a little bit less sensitive than other weeds. Next slide, please. A few words about soil biology, and we're not especially worried about electrical weeding and soil biology and impact on earthworms and so on, but we're not worried because the power is only applied under the row and not on 100% of the surface in the vineyard. So not especially worried, but it's part of our job to measure it. And we have a lot of enumeration points. Next slide, please. We have the plan of the plot, just to show that we compare e-weeding with biocontrol, with chemical weeding, and with mechanical weeding. So we check out the number of worms, and we check out the impact of bacteria and on mushrooms. So nothing more to say, because we have not all the measurements today. More results to come by the end of 2024. Next, what are the main challenges to make electrical weeding more competitive? We have still to work, in my opinion, on the optimization of the effectiveness, given the big differences in the first stage of the weeding. On the picture, you can see a lot of weeds under the row, and it's particularly difficult to have a big impact in this kind of conditions. So we have to work on the best solution to deal with this kind of situations. We have to also work on the speed of operation, because this is a big issue for viticulturists. They want to spend as less time as possible to do the operation of weeding. Safety and ease of operation seems to be all right with actual machines. The price of the machine might be also an issue to ensure that the cost of e-weeding is okay with or comparable with other weeding techniques. next point is the demand in energy to produce electricity. I think it's important because CO2 production using energy to produce electricity is a point of concern, I guess, and we have to measure it. Last point, maybe electric reading as a service might be a good way to make it more affordable for viticulturists. So a few benchmark in terms of cost. Next slide. Just to know where we are and where we are going with alternatives to herbicides. The first thing is that chemical weeding under the row costs around 250 euros per hectare and per year, while mechanical weeding, which is the most common alternatives to herbicides under the row in viticulture, costs around 500 euros per hectare and per year. So with electric weeding, this is still to be defined because we still don't know exactly which surface we are able to weed with one machine. How many number of intervention do we need per year? With what I know, 3 to 4 interventions might be a good number. And the price of the machine is might be a problem for the viticulturist because it has to be affordable to be used for the maximum of users. Okay, next slide. This is just a reminder that we are using electricity, so we need to think about safety first while using the machine. I guess this is important, even if, like Rootwave said, they have a machine which is safer. We take some caution still using the machine, that kind of machine. And I would like to thank you for your attention, and I'm still available for questions. Thank you.
So thank you, Christophe. So now we will spend some time on the questions. So I will just read some of them, maybe to start with viticulture, Christophe. I've seen there is a question about electrical weeding. So is there any solutions for precision in-row electrical weeding? So can we do it in the row, under the row?
Precision weeding makes no particular sense in viticulture because this is all or nothing weeding technique in viticulture. Of course, in other crops, you need to identify which is a crop, which is a weed to make precision weeding. But as far as I know, in viticulture, you just want to weed a certain surface under the row or in the interrow. But such a precision weeding technique would require weed identification and would cost a little bit more.
Okay, I also had some questions for, I think it's more for Ada's part. Some people are wondering about other weeds, for example, dandelion. I don't know how you say that. In grasslands, I have also hogweed, large umbelliferous, and ragwort in grasslands. So did you try it on other kind of weeds?
Yeah, I can take that question. Thank you. So yes, definitely high levels of control of dandelions in the trials we've looked at. So again, if they were within a grass sward, you would be perhaps touching the flower. It would depend on the height differentiation. So you do need that height difference, like Kevin was explaining with the dock. You need the dock to be at a different level to the grass sward. We have tested on hogweed and giant hogweed, and we get very good control. Again, that was with the handheld system. and it would be good for ragwort. I think my only concern with ragwort is that you'd need to consider grazing afterwards, because obviously ragwort can be very poisonous to stock as they're dying. So they're very palatable still to stock. So it's something that you need to the livestock, to the animals. So it's something you need to consider with a weed like ragwort. There are wider issues you need to think about, but yes, very good levels of control with all those species.
Okay, Kevin, one specific question about your results, your trials. Someone is asking what herbicide dose did you use in the combined treatment, full or reduced?
No, we used the same herbicide rates for the herbicide alone as for the herbicide in combination with the electrical weeding. And I think that was Docstar Pro at 2 litres a hectare, if I remember correctly.
Okay, I have one additional question on kind of weeds on rushes. I don't know what is rushes.
Okay, so I can imagine, well, we have not tested on rushes, and for one reason mainly is that they tend to be found in very damp, wet patches of a field. So I don't know, maybe if Tom has done any other trials with rushes, but it's not a species we have specifically looked at, but would be one of interest. So yeah, I can't comment on how effective it would be.
No, we haven't done any trials on rushes specifically because we haven't seen that as a target to really go for at the moment. But what I would add is that there isn't any resistance to electricity. So if you can see a weed or contact a weed with an electrode, you can kill a weed. So there's no cases of any resistance whatsoever, unlike herbicides. So I think that's interesting. And then also the electrodes, the way we design our machines is that the electrodes follows the contours of the ground. So to make as much contact with all weeds as possible.
I have some questions about time and cost for electrical weeding in grasslands. First, in case of big isolate weeds like docks or white thistles, how much time should be spent per single plant to achieve a good control?
So for the trials, we were looking with kind of 5 to 10 seconds per dock, and we were just trying to keep that as a kind of standardized time so that we had kind of a standardized level of treatment. Obviously, if you were in a kind of amenity setting and time wasn't so crucial and you had a larger weed, you could potentially spend longer with the probe on that. But for something like the docks, 5 to 10 seconds and you were getting complete knockback of the above ground growth.
So we were trying to simulate as if a tractor mounted system had gone through the field. But as Kevin said, if you were holding the probe and treating individual plants, you can see very quickly how they knock down. So you would be guided by what you can see in front of you. It's an instant effect.
And now about cost. I think it's more for the viticulture part. It could be for Christophe or Tom. So someone is asking for a tentative cost estimate of the machine and of each operation, even just the machine for now. Do you have a price or?
The cost depends on many hypotheses, and so the first is the price of the machine. I don't know how much the Rootwave machine might be cost on the French market, but anyway, the other part of the cost is the time you spend using the machine, and so just imagine you have to spend 2 hours per hectare with the machine. You can multiply 2 hours per the cost of the tractor and the cost of the user, and you add the cost of the energy. But if you can use a machine faster, up to 5 kilometers per hour, maybe, the cost will decrease fast.
Tom, at what price do you want to? Do you have references on the different markets yet, or?
So our go-to-market in the UK is direct. When we go into European markets, it'll be using our dealer partners as well. So obviously pricing is going to vary depending on the market. But I think to add to Christophe's point is that the way we look at the way we model the costing, it's on depreciation, fuel, which is a consumable, and labour. So you have the upfront machinery cost. So it's a different model to, say, herbicides, where you've got a relatively large upfront cost with e-weeding, but you've got very low consumable costs per hectare. But with herbicides, it's a little bit the other way around. Although some application machines can be quite high cost upfront, but you have a large consumable cost per hectare on the herbicide, which is opposite. So obviously, the more hectares you can put a machine across, the better, because you share that depreciation over a larger area. And it's like any machinery, you know, a farmer will budget their machinery cost based on the number of hectares that they use it on. So, for example, if we're looking at something like 60 hairs treated in a year, then we think that the cost, which is including the upfront cost of the machine, so the depreciation, fuel and labour, we think it will cost around about €300 per hectare, something like that. Now, of course, if you increase the hectareage even more, that cost is going to be reduced, and that's our target, and we think that's very realistic.
Thank you. I have another kind of questions more for Ilias and Nicoleta about Operate project itself. In the beginning, someone was asking, are you thinking of publishing the results of your project to the EU Farm Book platform?
Yes, of course, because we are also involved in the EU Farm Book project, so we will definitely publish all the outcomes there as well.
Okay. So I think for the questions, are there some more coming? I will wait a bit.
There's a last question.
Yes.
Will we get the presentations after the webinar? You can find the replay on the IFB website as from tomorrow noon on the webinar part of the website.
Yeah, and you will have it. So you will receive an email. All the attendees will receive an email tomorrow with a recording link and also with a short survey, satisfaction survey about this webinar. And you can also give suggestions for the next webinars. We will have one in October and then in 2024. So if you have any question, you will see on the website, Operate website, which is on the screen. You can find on it some contact information in case you have some more questions about the project itself or if you want to get involved.
We just have a last question. I don't know if you've seen it.
No, I didn't see it.
Did you have any information about energy consumption per unit surface? Thank you.
Yes, so I do. So I'm just going to look at a reference that I do have to feedback on that. So energy is the key question, I think, that does pop up quite a lot, because obviously electricity needs energy from somewhere to be converted into heat energy within the plant. So our studies looking at the fuel use, so it's the fuel use of the tractor on a tractor powered machine. We think it's going to actually be less than when you compare to chemical herbicides, because people quite often forget the hidden energy cost of herbicide production. So that's quarrying, large energy inputs into the manufacture and synthesization of the chemicals, as well as the logistics of transporting it all around the world as well. And so there's independent studies that have demonstrated that the actual, in terms of the megajoules per hectare, the megajoules per hectare, so we use glyphosate as an example, can be up over sort of 400, 450 megajoules per hectare. And if you look at our energy uses, our target is to actually go to around about 200 megajoules per hectare. So we're looking at almost half that energy compared to glyphosate as an example when using the label rates and the number of applications. Also, we compare with mechanical as well. Mechanical varies, of course, because you get handheld or hand-applied mechanical, like hoeing and hand weeding, up to very large cultivation tools, and that has a large range of energy. Our reference goes from like 10 megajoules per hectare up to over 800 megajoules per hectare. And then when we look at other thermals, they all tend to be pretty high, going up to, something like steam, for example, goes up to nearly 9,000 megajoules per hectare in terms of energy. So there's a huge varying. And the great news, I suppose, from an e-weeding perspective is that we have, we're very low actually on the amount of energy required per hectare.
And we have a last question. Can you provide information of electric generator voltage?
So that's, I guess that was probably for the generator. If we look at the handheld, I'm not so familiar on the handheld. I can provide that information with the notes after the call. I'll find the exact information for you.
We have an additional question for viticulture about specific species sensitivity, Conesa, Asteraceae. In your trials, did you focus on some specific weed species?
No, we didn't focus on any specific weeds, but we've just observed that in similar conditions, not all species react the same. So how to say this? Weeds are sensitive to electricity just depending on their size and the conductivity of their leaves. So obviously grasses are less sensitive because their leaves are very thin and they give less surface of contact with electrodes, while other species have larger leaves and give a big surface of contact. I think that's the key point, but other characteristics may play a role in weed sensitivity, especially the size of the root systems for perennial weeds. That's a problem. We have to spend a lot of time or to have more interventions on some weeds, even if electricity has an impact on all weeds, for sure.
If you allow me, Christophe, this specific question has to do with also the fact that the specific species, Conesa species, have a huge plasticity, meaning that many times they are considered as annuals, but many times they adapt their growing cycle. So if you have a weed emerging after a regrowth, you have a strong root under the soil, and this makes things difficult. However, I have to say here that we are talking about a weed that is already glyphosate resistant almost in all Mediterranean regions. So even a moderate efficacy of electric weeding would be very important for the farmers. Okay.
Of course, of course.
Thank you.
Yeah, and I think our experience in an organic scenario, it's more a case of the kind of the firefighting scenario initially. So there's really large weed burden So our hypothesis is, I suppose, really is that you would go in maybe more frequently to begin with to get on top of the weeds. So you may have to go in slower initially, and then when you get good levels of control, then you'll be able to do your maintenance applications where you go at your normal speeds. So it's like, I think it's probably like with any other weed control scenario. If you can get on a good management system in place and then do a maintenance application, that's the best way to use the technology.
There's another question here. Is the system effective against creeping perennials?
Yeah, I can take this question. So a lot of our trials focused on creeping thistle. So I showed some results with thistle, and so did Christophe. So we've seen really high levels of control with creeping thistle in the field, and also, well, not so much with couch grass, and then obviously dock species are not creeping species, but they have a very large taproot. So work we've done in previous blackcurrant work with docks, and also the work Kevin showed, we are getting very high levels of control of those quite persistent perennial weeds. So we don't have data to prove how that electrical current goes into the network of roots in a creeping thistle, but we are getting such good knockdown. Initially, you will be weakening and weakening that plant system all the time.
Thank you.
Yeah, that's our experience. So our experience of our handheld, looking at Japanese knotweed, which the product is used very successfully on. There's an example, a case study in the Netherlands where a contractor was using the Rootwave Pro machine to treat 1 hectare of Japanese knotweed. And so they treated the whole hectare in year 1. They had a reduction in year 2 and treated the remaining shoots. And then in year 3, they treated the remaining shoots. And then in year 4, they had less than 10 shoots return from 1 whole hectare. So you can see it's a management program, but you're getting a reduction, and then you can get on top of the weeds, and then it's a case of a maintenance scenario going forward.
Thank you. So I don't see other questions. I think that's it for today. So next webinar will be about other alternative weed control solutions and first results of Operate project. So we'll communicate about it in the future in the next month. Thanks a lot for attending, and thanks a lot to all our speakers today, all the presentations.